All right. I hope everyone has had a good Tuesday so far. All right. So today we are going to talk about functions, which is a very important part of programming. Probably some of the things that you've already seen or maybe had a sneak peek of, but now we're finally going to learn how to do them. Functions are integral to how we program and how we set up coding. Um, Also, another announcement is that today is our second to last class. It's our penultimate class, which means that next week is our very last class. So I really appreciate all of you sticking around for the summer, whether you were here on Zoom or watching the recordings afterward or a little bit of both. So I've really enjoyed this summer. And then next week we'll go over what it means when we have our last week of class, what we could do. There will be a final project that I will send out to everyone with a due date sometime in August, just so I have time to review it before the semester gets crazy for me, because I will be teaching a different class in the fall. So I've really enjoyed the summer. I hope you have too. And you know, uh, I hope that you continue to learn even past this class. Yes, Varun. Oh, I see. Okay, you had some trouble with the assignment. Well, that is perfectly fine because we are going to go over it. And all assignments are technically optional. Okay, yeah, we'll go over the assignment. Oh, I teach a class called Data Science Algorithms for our master's students at Vanderbilt. So it's a very fun class. All right. So before we dive into the assignment, let's have a little bit of a review on what we talked about with lists. So if you recall, we introduced lists last time, and then also some ways for working with lists. So lists we can create with those square brackets. See if I have an example. I don't think I do. Lists we can create with that square brackets, and then we have a couple of attributes of lists that we can go over. The first one is length, or LEN. This will give us the length of a list, or just the number of items in that list. Another thing to note is that lists are indexed starting at 0. So the first element in a list is going to be list 0. And remember, when we're indexing, that just means we're accessing whatever element is at this position. We use these square brackets as well. So list name and then 0. Um, Similarly, we can access any element, so the second or third or fourth element, using whatever number I. So if you want to access the second element in a list, you would say list name brackets 1, because we start counting at 0. So technically the first element is 0, the second element is 1, and so on. And then just as a little tidbit, you can access the very last element in a list by putting -1 inside of those brackets. That's just a little Python trick that you can do. And we also looked at looping over lists in a for loop. So instead of saying for I in range, we looked at saying, for I in list. And that is going to loop over each element. We'll loop once per element in that list. We also looked at some list methods. Mostly we focused on .append and .remove. Append will add an item to the end of a list. So we create a list, and let's say we remember with the fruits list, we created, banana, apple, orange, and then you can say list.append, and then whatever you want to add to your list. This is going to add something inside of your list. Remove is going to remove one item from the list. You put in the name of the item you want to remove. And then there's sort and reverse, but these are not as important, and you did not need them for your assignment. You mostly just needed this append here. But if you're interested, sort will sort the list alphanumerically. So if there's numbers, it'll sort it 0 to 10. It'll sort it in numerical order. If it's letters, it'll sort it alphabetically. I don't really see that used super often. Then the reverse list just reverses whatever current order the list is in, and will just reverse it. Again, I don't see that one used super often. Okay, so let's go ahead and just practice this. Practice this all together, and then the next thing we'll do is look at that assignment. So let's write Python code that constructs this list. Okay, so we've got 0, 4, 5, 9, 10, 18, 13. Okay, so these are just some numbers that we want to add to a list. So first thing we need to do is create our list. So I'm going to create a variable called my list. And how we create lists using what? What do I put here? I put brackets. So I have my brackets here containing my list. And let me just make sure I have those numbers that we need. I'm gonna pull those here. I'm not pasting them in directly because sometimes it has trouble. Maybe it won't have trouble. All right, let's see. Okay, it's totally fine. Sometimes when you copy and paste from PowerPoint, the commas are like encoded differently than Replit is expecting anyway. But it looked like it worked. Okay, so we have our list here. So we've just created a list. As a reminder, you just have, your variable name and then brackets, and everything in here is separated by a comma. And we're just going to do the following tasks. So first, add the number 10 to the end of the list. Add the number 10 to the end of the list. So if we look, so this is new, so it's okay if you don't 100% remember yet, but we can look at this here, look at our little review and say, okay, which method lets us add something to the end? Oh, dot append. This adds an item to the end of the list. And the syntax for that is the name of our list, dot append, and then within the parentheses, what we want to add. So that's perfect. So we're going to use the dot append method. And we're adding the number 10 to the end of the list. So I'm going to say my list dot append 10. And just to be transparent, I'm going to go ahead and print out my list after each of these changes so that we can see what happens and check ourselves, make sure that we're actually doing what we want. Okay, so here we go. So it prints out our list, and then after we run append, it prints out our list with the element 10 added. Great. Second, remove the number 5 from the list. So this one actually has the name of the method that we need in it, remove. You can go back to this slide here and see that this removes one item from the list. So our syntax for remove is the list name dot remove, and then the item that you want to remove. So let's try it again. I'm going to say add a value to the list. Comments are always good. Comments are always good to let you know what you're trying to do with each line of code. All right, so now let's say my list dot remove, and I think we wanted to remove the number, just trying to keep with the instructions, 5. Okay, so we want to remove 5. Now let's print my list again. Okay, so now on the second run, we see we have 0, 4, 5, 9. This is where we add 10 to the list, and now we have removed 5. Notice that this element 5 is completely gone now. Great. Sort the list in numerical order. Again, we're just going to we can use this as our cheat sheet, so this will let us sort it. So let's say my list.sort, print my list. And now our list is, so this is where we have removed, so we added 10, removed 5. This is where we've sorted it, so notice it's in numerical order now. And I imagine the next problem is going to ask us to reverse. Oh no, it's not, huh? So we have sorted our function here. If I had put in this reverse equals true, that would put it in descending order, so starting with the largest numbers. So that's how you put it in a reverse order. But we also just have that reverse function that doesn't sort it. It just reverses the actual order of the list without paying attention to the values. Okay, but in this case, we used sort. And we have all of our numbers in a nice little order. And then as our last instruction, it said, change the number 9 to be the value 11. So in this case, we can use indexing. Let's look at this output here. What index is 9 at in this list? Go ahead and put it in the chat. What is the index of the value 9? Yes, amazing. It is 2 because we started 0. So 0, 1, 2. Great job. Great job. I want to make sure we're on the same page. And I see a request to make my screen smaller so everything fits. I think everything should be fitting on it. Can someone confirm, is that for everyone or? Okay, some other people let me know if you can see my entire screen. But yes, so this is the index 2 here. So if we want to change the value at position 2, 9, or the number 9, see, can only see to line 12 and the right panel is half missing. I think that might just be your Zoom, and I'm not sure why that is. I'm so sorry. I don't know why Zoom is like that. Okay, so we're changing this value we're changing the number 9 to 11. All right. So now we're gonna have my list. We access the item at position 2. And now we're going to be, we're setting it to be equal to 11. So we're essentially replacing this 9 with the number 11. And now when we print our list, instead of 9 here, we should have 11. And sure enough, we have replaced that. So that was just a very quick review of everything that we can do with lists, what we covered last week. And are there any questions about lists? I will be going over the assignment. But I always want to take a little pause for me to drink water, but also to see if there are any questions about lists so far. Okay, so let's look at this assignment. So assignment adding machine. So one thing about assignments that I've been noticing is the use of either ChatGPT or like the automated suggestions, like this AI thing in Replit. Personally, I turn this AI thing off, especially while I'm the AI autocomplete. If you're in Replit, you can hover on this AI thing and then enable or disable it. I have it unchecked so that it's not enabled because it allows me to that's mostly for teaching because I hate when it's trying to autocomplete while I'm trying to teach. But I also recommend that maybe some of you turn it off because I think you might be relying on it too much. I'm all for using our resources, but I have received a couple of submissions of assignments where the code is like super complicated, and I have a feeling that AI wrote it. And this is just a class for fun, so no one's in trouble or anything. I'm not really bothered. But if you want to actually learn these concepts, if you want to learn how to code, I highly suggest that you don't rely on the AI in this point in your coding journey, because you need to be able to understand what the AI is giving you to be able to use it. And I've received a lot of code that is wildly complicated that I don't think the students wrote. But that's all I'll say about that. So always try to further your own learning. Use the resources that you have, but make sure that they're actually helping you learn instead of just completing something for you. I'm just taking a screenshot of what we did here and putting it in. I'm just going to put it in here for now. Awesome. So if you want that code, I have a screenshot there of what we did. Okay. Yeah, and if you're struggling with something, so like, ChatGPT, it's a little weird. If you're struggling with something, I highly recommend ChatGPT. It's great to ask questions, say, I'm struggling with this, I don't understand what this question means. Or say, how do I ask for input in Python? How do I get input from a user in Python? For very specific questions, it's amazing. Really great for learning if you use it to ask questions and not just write your code for you. So, if you're really stuck on a problem, then do use ChatGPT, but then make sure you understand what it has given you. Like, if it gives you just a whole page of code and you're like, I don't know what that is, that's not helping you at all, right? But if it's giving you like, oh, you can use the input function to request input from a user, and then you can use append to add something to a list, then, that's a really great use of ChatGPT. Varun. Oh, yes. Yeah, asking it for a detailed explanation is a really, really great strategy. So, I'm not against ChatGPT whatsoever. I mean, we have classes on, we call it AI assisted programming. Um, but if you're wanting to learn Python for the purpose of writing it yourself, then you need to at least understand Python that AI gives you. Okay, anyway, slight tangent there, but let's go to this assignment that we got. So I'm just gonna take this text so I don't have to keep going back and forth. And I took a screenshot of this, so I can erase it. Awesome. All right. So here are our instructions. Create a program that asks the user to enter a number, asks the user to enter whatever, asks the user. You should be thinking the input function. Remember, we use input to get input from the user. Use a loop to continue asking for a number until they enter Q. All right, so some sort of loop. And then until that's telling us, until something happens. That's telling us there's some condition. So that's saying while loop. And then print out the sum of the numbers. And I put a little hint here. Store the numbers in a list. All right, so let's start with this first part. Ask the user to enter a number. So I'm gonna say, user input equals, and because we want them to be numbers, I'm putting that int around it already. And I say input, enter a number. And remember, if they enter Q, we want some sort of program where if they can enter a number, or if they enter Q, then it will quit out of our program. So this is a very common, we call it, a user interface. It's a very common strategy when you are checking user input, if you want to put that in a loop to say, enter a number or Q to quit, and then have something checking if if they enter that keyword or Q or whatever. Okay, we also want to store our numbers in a list. So I'm going to go ahead and create a list called nums list, and I can just create an empty list just like this. Just open bracket, close bracket. You can also do something like that if you want it to just be list, but I just like doing that. It's very fast. All right, now we want to do a while loop to continue asking the user for a number until they enter Q. So what condition can I be checking here? Well, I want to check the user input, and I want to check if it is a number or if it's Q. So what I can say is while they're entering a number, while it's not equal to Q, we're going to run this loop. We're going to continue asking for a number. So while user input does not equal Q, ask for user input again. So enter a number or Q to quit. Okay, so we have our loop, but we need to keep track of what numbers the user is entering, right? Because eventually at the end, we're gonna print out the sum of the numbers. So we have nums list. How do I add this user input to my list? Go ahead and put in the chat, how do I add this user input to this list? Using some of the methods that we discussed. Yes, append. Great, great, great. So we could say nums list dot append user input. Awesome. So for this first one, we can say, enter a number or Q to quit. Nums list dot append user input. We also want this going on inside of our loop. Append user input. So let's look at what we have so far. So we've created an empty list. We ask for user input the first time before there's a loop. We say enter a number or Q to quit. Append their input. While user input does not equal Q. So one thing that I caught, okay, let me go through this. While user input does not equal Q, ask for the input again, and then append their input again. One thing that I caught while I was looking through it is that if the user enters Q the very first time, then we're adding Q to our input, and we're actually not checking. We don't want to add Q to our list here. So what I'm going to do is take that away, take this away. We're going to check, right? This is only going to run if the input is not Q. We're going to append to our list and then ask again. And then our while loop is checking that it's not Q, right? So we need to be able to check because we only want this to have numbers in it because we're going to add everything together. So now let's go over what we have. We have an empty list. We have something asking for user input, enter a number or Q to quit. Now we're going to enter our while loop while that user input is not equal to our quit word, our Q, then nums list, we're going to append that user input, and then we're going to ask for more numbers again. Awesome. And then as for the final portion of this, we can print out the sum. I don't think we went over the sum function for lists, but what you can do then, if you want to use for loops, you can say for I in nums list. I'm going to keep track of a total. For I in nums list, total, let's equals I. Print total. So what this is doing is we set up some variable to hold our sum or our total for each value in our list. You can iteratively add that. So total plus equals total plus I plus equals is just a shorthand for that. That's what that shorthand is for. Okay, hold on. Make sure you raise your hand so I can see who's talking.
I don't see a way to raise my hand. I'm sorry.
Oh, that's okay. It's on Zoom. All right, for next time. I think I see you popped up on my screen this time, though. Hello.
Hey, don't we need something to make sure they don't enter any other letters, that it's either numerical or Q?
You could. You definitely could, but I would say that's more of a bonus than something I'm expecting you to do. But that's a great point. Yes.
Okay. Thanks.
Yeah. Great question. Yeah. So sometimes in an assignment, I might say, check that they're only entering numbers or something, but that is a great place to be thinking because that's a great programming skill to have, is thinking of what other things a user could enter. So yes, if you would like to add something in like that, you definitely can, but you don't have to. Okay, so total plus equals I. All right. So I'm going to show you another way, though, that is much easier to sum, and mostly the reason why I wanted you to use a list. was you can also have total equals sum nums list. This is just a Python function where you can give its sum. You give it a list and it will return the sum of a it will return the sum within that list. So pretty nice. I didn't teach you that though. Some of you maybe already knew it or got it from another resource or something. But so let's go ahead. I'm going to print, just show you that it works. Print total sum function. Okay, and then let's get rid of all this. And let's test out our program. All right, so enter a number or Q to quit. Notice I didn't put any space here, so my number that I enter is just going to be right next to that letter right there. That actually does bother me, so I'm gonna put a space there just to make it look nicer. Okay, so now enter a number or Q to quit. Say 3, press enter. All right, it keeps asking me for this number. I'm going to say, ooh, -1, 10. Okay, and now I'm going to say Q. Oh, what did we have? Oh, and the exact thing happened that you warned us about, Ian. Oh, because we're checking that we're automatically converting it to an int. So what we need to
You
do
can call me
here.
Cassandra.
Oh, okay. Yes, yes, yes. You predicted the future for us. But that's okay. This is a great experience to show what you do when you get an error. So it's saying invalid literal int with base 10 q. So what we did do is we told a user they could enter q, but we're automatically converting it to an integer. So actually, we don't want to do that here. So get rid of those int parts. Only convert it to an integer, right? When we're appending it to the list. So just use input. Don't convert it to an integer yet because they might enter q. Nums list.append integer of the user input if it's not equal to this letter, right? Okay, and now we're assuming that they're not going to enter anything other than a number or q. All right, let's try again. Okay, a number or q to quit. There we go. And that worked. And there's two 14s here because I was showing you two different ways to print the sum of something. So we have this first way with a for loop, and then another way with just the sum function, which is very nice when you're working with lists. Awesome, awesome. Great, great, great. Okay, any questions about this? I'm going to put a comment in here and then also put that screenshot in the slides as well. So I'm using for loop. Okay. Great. So I've saved that in our slides here for you to review. All right. Yep. If you get errors, put them in the chat and our TAs can help you with those. Okay, great. So this is now in the slides. I know some people like to copy the code before it goes away. So just gonna put as always, we have these slides here, but in case you don't have easy access to it, there it is. All right. Functions. Let's jump into functions. So what we have been talking about with programming. Programming is a set of instructions. But we kind of just write the instructions in a file. But what if I want to reuse it? So when we're doing this whole thing, what if I'm in some other function and I'm like, oh, I want some other program and I'm like, oh, I want this code that asks the user for a number or cue to quit. It doesn't really matter what it is, but what if I want this code again, but I don't want to write it all again in like a separate file or something? What if I have some sort of useful piece of code that I want to reuse? Well, we can actually save our code, not just in a file, but we can save the instructions by creating a function. So for example, the print function. Python was very nice to us and provided this print function that takes whatever string or variable you put inside of the parentheses here and then puts it on the console. This is very nice because now we don't have to keep writing the code that under the hood does what the print function does, which is print stuff to the console, and we can just use it. This is a built-in Python function. But we can create our own functions to use within our code. We don't have to just use the built-in Python functions. And this is what a lot of programming is based on, is writing functions. So what exactly is a function? You can think of a function if you've, maybe in high school math or something, you've seen, f of x, a function that takes x as an input and then outputs some y, right? Whoa, taking it back to math class. It's a very similar idea in programming where you give some sort of input. That could be no input, it could be some amount of input, and then the function gives you something in return. So, but it is performing some specific set of steps. Now, the first step in writing a function is defining it. So to write a function in Python, we're going to use this def keyword along with whatever you want to name your function. You're always going to follow that function name with parentheses, and we can talk about that later. But if we're defining a function, use this def keyword, def my function, open and close parentheses, and then a colon, because we always have those colons when we're defining, loops or if statements or functions in Python. Let me show you what this looks like. So let's say, all right, so I took a screenshot of this so I can erase it. Okay, so let's say I have, something that says print hello. And instead of writing, this print hello over and over and over again, I want to save it into a function. So what I could do is define my function. I'm going to say define greeting, naming my function greeting, open and close parentheses, colon. So this is how we're going to define any function that you want to write. And then the code for my function goes indented, just like with loops, with if statements, the code is indented here. Oops, that was too many indentations. So if we wanted some sort of function that prints hello, we can define it here. One thing I want you to notice though, is all we have done is defined the function. This is not going to run the code because the define function is like telling Python, hey, I'm going to give you a secret, I'm going to give you a task called greeting. I'm not telling you to do it yet, but when I do tell you to do it, this is what you do. It's kind of like giving someone instructions in advance, but don't act them out yet because I haven't told you to yet. Kind of like Simon Says. So we've defined our function here, but if I run this, nothing happens, right? Because what we actually have to do is something called calling our function. But right now we're just talking about defining our function. All right. So defining our function, use that def keyword, the name of your function, open close parentheses, colon, and then everything within your function is indented. Okay, yep, that's exactly what I just talked about. Sometimes I get ahead of my slides. So just a little, I like to have diagrams sometimes. So this is the syntax of defining a function. You have your def keyword, your function name, parentheses, the colon, and then actually where your code lives within that function. Show that just for a second. It's like you're creating a task and then giving a name to it. So now let's talk about calling functions. This is actually when we run the code inside of the function. So when we define it, we're not running the function, but then we can call the function to actually run that code. And all you do to call it is just put the function name and the open close parentheses. So if I define a function called say hello, then to call it, I just write out the name of the function, say hello, and then those parentheses. Once you have defined a function within one file, it becomes a command you can then use in the rest of your Python script, in the rest of that file. We're not going to get to how you can save a function for use outside of your file or in, a different project altogether. That's for a more advanced Python class. But in this class, we're going to look at defining our functions within the file and then calling them later within that same script. So let's try it out with our example here. So we have, greeting, very similar to the one in the slides. And if I actually notice that when I ran this, nothing actually happened, right? Because we didn't call it, we just defined it. But now I can call it here, hit run, now it says hello. The great thing about functions is you can call them multiple times. So now I call it, greeting, greeting, and it prints hello, hello, right? So we can have, however many amount of calls to this function as we want. And you can imagine as this function gets longer and longer, just being able to call it with one function name becomes more and more efficient. So let's say this function is, like so ever many lines of code, imagine code all here where it's like 10 lines of code or something. Then just being able to call it 3 times by writing the function name 3 times is a lot less work than, putting all of these lines of code again. That's why we like functions. It allows us to repeat tasks in a way that improves efficiency. And very, very important, just like with variables, you have to define a function before you call it. You have to define that function before you call it. It's like an introduction for Python. Python will not know what that function is if you have not defined it yet. So if we ran, so let's look at this. So if we put the function call before our function definition, we're going to get an error. And it says name error, greeting, not defined. Remember, we can read these error messages. This is another great way to use ChatGPT. Put in your error into ChatGPT. It's usually pretty good at helping you. But it says greeting is not defined. That, yeah, we haven't defined it yet. Remember, our programs go line by line. So don't do that. Make sure you have defined your function, introduce Python to your function before you call it. Okay. So let's look at that example here. We've got your function, and then just to call it, you write the name of the function. So here's where we're defining function, and here's where we call the function. Sometimes I like little diagrams. Okay, so you've probably seen this before. Well, you have seen this in some of my examples. If you've been paying close attention to the examples, you may have seen something saying def main. Main is a common name given to define a main body of code. Sometimes we will have a really large function that's our main function. It's exactly what it sounds like. It's our main function. It's kind of in charge of calling the rest of our application or our coding project, and we define that as main. This is just a very common practice within Python is for all of your code to be within the main function. So now I'm going to ask you to do that, and I'll show you what I'm talking about. So you may have seen, let me find some of my other I know you're seeing a different screen right now. That's okay. All right, I'm just looking at for some other examples because I know I have given you, look at this. Here's an example. So def main for I in range 0, 5, print I, right? So this is our main function, and that's what I'm talking about. And in past classes, sometimes I introduce this first and tell students just not to worry about it. And then in other classes, I don't introduce this first. It just kind of depends on what I'm feeling in the moment. But this is an example of a main function, and all it's doing is just saying this is my main block of code. So, okay. Now let's look at naming functions. What can we name them? Well, much like variable names, they need to start with letters. They can only contain alphanumeric values and underscores. And unlike variables, function names, how we know that they're a function is that they have these parentheses at the end. We're not going to use these parentheses just yet, but we'll see sometimes, remember with print, you put something inside of those parentheses. We can have our functions take something inside of the parentheses as well as input, but we're not quite there yet. But we'll get there. So if we wanted this function, say hello, we define it. All the code in the function is indented. Print hello, right? Okay, so back to those parentheses, I said we'd get to it later. Well, it looks like now it is that later time. So some functions can take information from what we call arguments. These are the things inside of those parentheses. So if you don't leave them empty, you can put things in there that are called arguments, also called parameters. There's a whole there's a whole argument about what they're supposed to actually be called. But in this class, we're going to use the word arguments or parameters interchangeably. Arguments are going to be defined in the function definition inside of those parentheses. And then it can use those arguments that you give it as variables inside the function. So it's kind of like giving input to your function and allowing it to use different inputs that you give it. So let's say that if we want to define a function that says hello using a name, we want to be able to give it that name. So we have def say hello, and then we say, okay, you're going to be able to use this variable name. So it says, so we could say, okay, print hello, comma, name. Now when we call say hello, we can no longer just do empty parentheses. We have to provide a value for name. So you call the function and then also include that argument there. Let's look at an example in Replit. Oops. So in this example, we're calling it greeting. Right here, it's just printing hello. But let's say we want the user to be able to specify, or the coder to be able to specify a name to say hello to. So in this case, we can say, give it name. And now name, all this is doing is saying you will have, this function will be given this variable. And then when we call the function, whatever we put inside of the parentheses is going to be assigned to this variable. So now we can do something like this. Hello, name. And when we call the function down here, we put in something that corresponds to this argument that we have put in. You can also do that if that makes more sense to you. This is also acceptable, saying, specifically name equals this. But you can run into problems when you get more than one, so I just recommend doing that. So let's run it and see what happens, right? So hello, Miranda. But now we can change it to say, Python. Hello, Python. So this is a way for us to define functions and allow them to take some sort of input and use a variable there. We can actually do more than one argument. So that was just an example of one argument. We can do as many as we want, pretty much. So let's say that instead of saying hello, we want to be able to specify to customize the greeting that we do. So, we can say hello or hi there, or even use a different language if we wanted. So in this way, we have a fully custom function where we say, okay, say hello, greeting, and then name, and it's going to print that greeting and the name that you've given it. So one thing to note is that these arguments that you send to it are assigned in order. So what your function is doing is assigning this first string here that you've put inside the function to the first argument that it has named, the second one to the second one. So you need to be cautious, be aware of what order you're putting these in. Ian, yes.
Hey there, is there a way to, like I know in JavaScript you can put in, variable dot dot dot. What's it called? Forget. Is
Like
there a way
accepting
to
more than
do,
one?
what's that?
Like accepting more than one?
Yeah, you can have, one and then spread operator, which will let you put in as many as you want. Is there something like
Hmm.
that in Python?
Yes, it's almost the same. It's also dot dot dot. But I think
Okay,
you can just put we won't a little bit outside of what we'll be doing, but you can. I think it is also called the spread operator if you want to look it up for Python.
great,
Or if
thank you.
someone, yeah. If someone has documentation on spread operator ready, feel free to put it in the chat. But yeah, great question. Thinking ahead. But yes, but for defined, if you want to put a defined number of variables in there, we can put in our arguments in this order. So let's just look at an example of this. So now let's say we want to customize it again, right? So that is why I didn't name it greeting. Okay, say hello. I'm going to say phrase and then name. Notice I didn't name it greeting because our function is named greeting, and that might get confusing. And so instead of just saying hello every time, it's going to print a phrase and then the name that is assigned. So now when we call it, we have to put both of those arguments in here. So if we call this, then I can say, hi there, comma, and then Miranda. Oops, Miranda. And now if I run this, it says hi there, Miranda. And you can keep going if you want, adding more variables to use in here. One thing that I want you to notice though, is if I call the function and I don't provide both the phrase and the name, error. It says greeting missing one required positional argument name. And again, we can just read this error just as is. It says missing an argument name. And sure enough, we only provided one, so it's going to assign this to phrase, and then there's nothing left for name, so it has no way to assign it. Same thing if we don't assign anything, now it's going to say missing two arguments, phrase and name. So once you put these arguments in here in the function definition, you have to assign them within your function here. All right, so let's look at some examples. Write a function that takes two numbers as arguments and adds them. Yeah. So let's look at this example here. So we need to define our function. So I'm going to say define, say add numbers. Now we need it to take two numbers as arguments, right? So we define those right in here. So say num1, num2. Don't forget your colon. And then what we're going to print, I'm just going to print it. Print num1 plus num2. And now I can call add numbers. And now I have to supply the two numbers that I want. Clear this. And if we run, then it does exactly what we want. We have an add numbers function that takes two numbers as input and then prints that output there, prints their sum. Same thing. You could even do, num3. Just make sure that you use it within your function and you provide that argument. But you can have, as many as you want. So if we wanted to add 3 numbers, we could do that same thing. Okay. Seeing with the time how much I want to cover. Um, Okay, one thing that I want you to note is we do have to provide each of these answers here, each of these arguments here. I'm just going to make it down to 2 numbers again. But let's say that we mostly want to add the same numbers each time. Like let's say 3 and 4 are numbers that we want to add a lot together for some reason. Well, in this case, we can set default values within our function definition. So if you want to give an argument a default value, you can use that assignment operator. And this says that if no one is entering, if you're not entering any sort of input, assume that num1 is assigned to 3 and num2 is assigned to 4. And then this way, if we don't provide any arguments in our function call, it will still run that as if num1 is 3 and num2 is 4. You can then override that if you wanted. So this is just a default, right? It's just a default, but we could override it by putting in the actual ones that we want. So we could say num1 equals 4 and num2 equals 5. If we wanted to override that default, you're going to need that assignment operator again. So now we've overridden it and it's adding 4 and 5 instead of 3 and 4. Let's look at a non-math example because I think that greeting example makes more sense. So if we want to define our greeting function again, let's say, phrase and then name, print phrase, comma, name. And then we can call it, right? And we can say hello. And then Miranda. But let's say that, the most common phrase we want is going to be hello. And then the most, let's say we want it to be Python by default. So the phrase is hello by default and the name is Python by default. Then we don't have to go ahead and provide that. Makes a little more sense when it's not the math one. So now if we run this, it's going to say hello Python, even though we haven't put anything in here. It does get a little tricky. I'm not going to get into the weeds with this. It can get a little tricky with these assignment operators here. If you assign a default value, so let's say that we want a default value for the phrase, but we don't want a default value for name. So name needs to still be specified, but phrase needs to be, phrase can have a default value. You get a little tricky with this order, so I'm just going to show you what's going to happen. So you're going to get a syntax error if you try to do something like this, where you're mixing in default values and non-default values. So what you need to do here is if you're specifying a default value for only one variable or just not all of the variables, this one needs to be listed last. So if name needs to be specified each time, but you're having a default value for phrase, then you have to list the default valued ones last. And now it works. Don't ask me why, because it can get us off track a little bit, but just know that if you're going to have a variable with a default value, you have to list that last in your function definition. That way, because it's I don't know, I'm not going to explain it. It's a little complicated, but most of the time I just recommend either don't provide default values or provide default values for, all of your variables or something. And then in this one, let's say we wanted to use a different phrase. So let's look at providing a different phrase. You say, Guten Tag. And so in this case, we're saying override that default phrase. And now it says Guten Tag, Miranda. Wonderful. Okay, and if you want, yeah, another example of that is in our slides here. Okay, so one more thing that I want to show you before our class ends is that so far our functions have only just run code and then just ended when the code stopped, right? So code, that's it. But we can make functions communicate with other parts of code by adding a return value. So in our functions, nothing really happened except maybe a print statement. But let's say we want to save a variable to the result of a function. Currently, the way we have it set up, we can't do that, right? Like currently we just have this print statement. But what if we wanted to save this as a variable instead of just printing it? Well, we can use what's called a return value. And this is where, if you're thinking of functions like in math, you have an input and an output. That output is a specific value that we can then access in other parts of our code. So this uses the return keyword, it's just the word return. And sometimes you may see this as just return and it returns nothing, and that's fine. That's called a void function, but you can return a value using this return keyword. So let's see where I have that example. And then whenever the function is called, whatever it is returning is that value that it's giving back to the line. I'll show you an example. Where's my example? Okay, so in this one we have define, multiply by 2, given a number. So now we're going to have our new number equals number times 2, return that new number. Now when we call our function, we can actually assign it to a variable. So we can say number times 2 equals multiply by 2 number. Okay, so if we wanted to apply that to this, instead of printing this phrase, what if we wanted to save it as a variable? We can say return name, yeah, return phrase plus name or something. Or I'm going to say, full greeting equals name plus phrase, and then return full greeting. Then this allows us to use this variable here in the rest of our code. So now I can call it whatever I want. Say, I'm just going to call it a variable. Hello equals greeting. And now if I run this, nothing's going to happen, right? Because we're not printing anything. We're saving it to this variable. But then if we want to print the variable, oops, I didn't do it right, but that's okay. When we print the variable, then we can print it here. It needs to be, to fix this, it needs to be phrase plus space plus name. There we go. Okay, so being mindful of the time here. I think we have covered enough to do these assignments. I have a little bit more for you, just so you get extra practice. So if you have time to do them all, then I encourage you to, but if you don't, that's fine. So for this first assignment, I want you to write a function that takes a list of numbers as an argument. The function should return a list of Booleans representing for each number whether that number is even. This is a bit of a more advanced problem. Maybe I should put them in order. So for instance, if the input is a list 1, 2, 3, 4, 5, then the output needs to be false, true, false, true, false, because it's saying, is it even false? Is it even true? Is it even false? All right. Next assignment is just trying these exercises from W3 School's website. So if you click on this, It has a couple exercises and extra reading on functions. I highly encourage that one if you want more resources or you want to read more about functions first. And then finally, I have created a slide with some review problems that combine a lot of the concepts that we have been going over so far. So namely, loops, if statements, and lists. So I have two problems here that where you will need a loop, a loop, an if statement, and a list involved in some way. So if you're interested in getting more practice with those, then please try those. Okay. So please do use the slides as your resource while you're doing this homework. I try really hard to make sure that the assignments, we have covered everything you will need for the assignment. But if we don't, remember, we're just having, fun with this class. So don't get too frustrated if the problems are a little more difficult now. But I hope this gives you something to work on in the next week. Next class will be our very last class, and I will assign our final project. So I'm looking forward to seeing you all then. Thank you so much for joining me today. And that's all that I have for you. So class dismissed. If you have questions, feel free to stay on. Right. For those still on, did you have any questions? Cool. You brought up some great points today, Ian. Thank you for that. I always love that.
Sure. I just curious minds want to know.
Yeah, I understand. Awesome. Well, then I will see you all next week for our last class.
Take care.
You too. Bye. Thank you, Brendan.